You're listening to a podcast from 702 and Cape Talk.
The Naked Scientist.
Oh, Chris, forgive us. Good morning.
Good morning.
Hey, thank you so much
It's my turn to have a go. Can I have a go?
Thanks indeed. Our lines are open for you for The Naked Scientist on 021 446 0567, 011 883 0702. And Chris, we start with a story that we took off The Naked Scientist website, that chicks can count.
Yeah, it's extraordinary. But in the last week, we've had this paper in the journal Science, and researchers there in Italy actually have been not counting their chickens, but making their chickens count for them, because they did some simple experiments where you basically present chicks with pieces of card with a certain number of spots organised on them, and you present them in an order left to right or right to left with ascending numbers of spots. So the more spots there are, they're over to the right or over to the left in order. And the fact that birds probably have some concept of number comes from the fact that if you look at, say, a peacock, then on a peacock's tail you have those eyes. Well, female peahens can discriminate or will discriminate against males that have fewer eyes in their tails than the ones that have most. So there's some idea that birds might be able to count. Well, when they actually did these experiments with dots on cards and put food behind cards in certain places in the order for these chicks, they found that the chicks looked preferentially at the higher numbers before the lower numbers when the higher numbers were on the right. And you say, what's the relevance of that? Well, if you look at a ruler, you will see the numbers go from left, 0, to right, 30 centimetres. We, as humans, have evolved, it seems, to order things in a numerical sequence from left to right. It now appears that these chickens are doing exactly the same thing. So way back in evolutionary time, probably 300 million years ago, when we last shared an ancestor with a bird, because birds are direct descendants of dinosaurs, we spun off as the first mammals maybe 120 to 200 million years ago, so we're a little bit younger, but similar sorts of origins. There must be either some kind of similar source in our brains that we shared way back then that organises things this way, or we have convergently evolved to process things in this way because it makes sense. But web designers know this fact very well, actually, because if you look at where people design or how they design and format web pages, most of the information that you need to attend to tends to be presented on the left. And that's because the right side, the visual side of your brain, is your right brain, which means it's very good at decoding that sort of information presented on the left. So that's why web page designers, because most of us work that way, put their information over to the left where they want the adverts to be most potent or want you to attend to.
Lovely. Barris in Bloberg. Good morning.
Good morning. Morning, good. I was watching a YouTube video on how to make water from hydrogen and oxygen, and the spark that's required. How possible is it to make it on a larger scale? Say for desert areas. Why can't we make water from that technique?
Okay, your line wasn't great, but I think we got the question. Why can't we manufacture water or make water? Yeah.
Well, we don't really need to manufacture water because water is one of the most abundant molecules we have on planet Earth. There's several million cubic kilometres so I think it's X number of 3 billion cubic kilometres of water on Earth. It's a huge volume of water that we have. So we don't need to make it. Actually, what scientists are usually trying to do is to reverse the chemical reaction of 2 lots of hydrogen plus 1 molecule of oxygen goes to 2 molecules of water, because hydrogen's a useful fuel and it can be oxidised by another very abundant gas in our atmosphere, oxygen, to turn into water, which is a very stable, safe, non-polluting product. So actually, scientists are currently working on various ways of doing that and doing it more efficiently so that we can take energy from the sun, for example, with a solar cell, and then electrolyse, put electricity into a solution of water, and then you split the water molecule apart into hydrogen and oxygen, and you can then store the hydrogen, or you can then later burn the hydrogen in the presence of the oxygen to re-release energy. And that's a good way of effectively long-term storing the energy in sunlight.
All right, thank you very much, Barris. Is it Patrick in Khayelitsha? Also, your question is also related to water, rainwater this time. Go ahead.
Yeah, good morning, everybody, and the Naked Scientist.
Yes, good morning.
My question is, you seem to have touched on it last week, that the rain favors weekends. I grew up, I noticed that, I observed that usually, and then I thought maybe my teachers were, God listened to their prayers. Because we would wish that it would not rain during the weekend. Then Monday it can rain. Then I can have good excuse not to go to school. But it usually favors weekends.
So it rains weekends.
And the second question also.
Yeah.
In my culture, which is Xhosa, women were barred from eating meat of a bull or any uncastrated animal. The reason it seems was that to curb promiscuity. And then I want to make scientific sense of that.
This whole idea about whether or not women should eat meat from an uncastrated animal. This stems from the fact that if you have an uncastrated animal, it will have high levels of testosterone circulating. And could that testosterone have an effect on the women? Well, the testosterone, when you eat the meat, there will be a little bit of it being absorbed into the body, but women do make testosterone. They have about a tenth of the level of testosterone that men do, and they have other androgenic hormones, and this is actually responsible for a lady's libido. So you don't want women with no testosterone, or men are not going to get on with them very well necessarily. But the actual impact on a woman from eating meat from an uncastrated animal is extremely remote, that there's going to be any kind of problem from that, I would say.
Mm-hmm. And the rain bit, well, Chris, I can tell you that every evening I pray that it rains between 4 a.m. and 6 a.m. because what that means is that I don't have to get up to go running. And it will rain in the evening.
You should just move to England. It rains all the bloody time here.
It will rain in the evening and the afternoon. I think, yes, I can lie in tomorrow. And then 5 o'clock, it's nice and fresh. And yeah, we never get what we want. Frick in Edenvale, good morning.
Good morning to you, Reddy, and Dr. Chris.
Mm-hmm.
The question I have is, how come animals can sense a change in weather patterns, i.e., an hour ahead of a storm, a thunderstorm in particular, our dog would know that there's a storm coming. And similarly, years ago with the advent or the tsunami that hit Indonesia, the animals actually fled higher ground before humans knew that there was this massive tsunami going to hit the islands. Thank you.
Morning, yes, very good question. And the answer is that if your life depends on something, and it depends on that same thing over many, many generations, then you become very good. You evolve to become very sensitive to the environment in which you live and have the ability to sense that environment. And this is not a new phenomenon. In fact, a few years ago, there was a big earthquake in the middle of Italy. And scientists published a paper in the journal Current Biology where they had gone to this same region of Italy to study some toads, which come to a certain lake or a certain part of a lake to mate at a certain time of year every year. And they all arrive in massive numbers, go through their mating, and then they disappear. They hop it, I suppose you could say. And on this one occasion, these toads turned up, they began this mating cycle, and then all of a sudden, they abruptly vanished way sooner than they should have done. A little while later, there's this massive earthquake. And it's only later, after all of the aftershocks have disappeared from this earthquake, that the animals began to return, and then they sort of went back through their mating. In other words, the researchers were sufficiently convinced that the animals were responding to some kind of signal before the earthquake struck, and they knew to abandon ship, as it were, and disappear into the bush. Because of the interesting correspondence in time with their behaviour suddenly switching and being out of normal characteristic in it switching, and they're only returning after the aftershocks had finished. There are a number of suggestions about this. One is that there may be some kind of heralding signs coming from within the Earth. It may be that perhaps when the Earth is going to have an earthquake, that there are other signals that affect, say, the Earth's magnetic field in some subtle way, and this has an impact on the magnetosphere, which affects the way in which solar radiation comes in or other cosmic radiation comes into the Earth. Perhaps animals pick up on that. It's the same with these storms. If your life depends on it, you are very sensitive to what the environment is doing, and you learn to read those signals ahead, because it may make the difference for you between life and death, and therefore the difference between whether you get to pass your genes on to the next generation. So animals are very much better attuned to their environment often than we are, because we are savvy enough and intelligent enough to build ourselves more defences and better homes than they can. And I think that's really the crux of this, that you've got the ability to sense your environment and take avoiding action, because animals have very well developed senses. I mean, a bee can see ultraviolet light, for example. We can't do that. So even on a cloudy day, a bee can use where the sun is in the sky to navigate itself. We can't do that.
Okay, and just before we move on, we're getting a lot of calls. This is just to acknowledge them. The calls and SMSs that there's a heavy police presence with armed security guards as well on the Greyston off-ramp in Sandton. So Eyewitness News is looking into it. Thank you, all of you, for letting us know. Can we go to Leon then in Randburg? Good morning.
Good morning, Jerry. Good morning, Chris. Very quickly, I just want to know if there's any loss of vitamin content in stewed fruits or tinned fruit salad, these sort of sliced peaches, that sort of thing. I know there is a variety that is not only just tinned in a fruit juice, but in the actual juice as well. But I'm more interested in, is there a loss of vitamin content?
Hi, Leon. It's going to vary from one product to the next and how the fruit is treated in order to make it preserved and stable and shelf stable. If it's well dealt with, it hasn't been boiled or cooked to within an inch of its life before it goes in the tin. So actually what's going in the tin has a reasonable vitamin content, because when you heat these things up to stew them, for example, you can break down a significant proportion of the so-called good stuff that's in there that you're eating them for. But once they're in the tin, as long as you don't then throw away the juice, for example, what goes into the tin can't disappear in the tin, with the exception that there are some small amounts of chemical reactions that can happen. Some preservatives will react, for instance, with vitamin C and can make benzene and things in the water. So you have to be a bit careful, but on the whole, what goes into the tin should be what comes out of the tin.
Thank you very much. And then, Chris, I remember you once came to 702 and I wasn't around, and you left a note on my desk about my clutter, right? So
I think I said it was from the management saying, clear this mess up or you're going to get the sack or something.
Yeah. So a couple of years after that, I was reading something, and I've just seen it again, that scientists have found physical clutter negatively affects your ability to focus and process information. And yet a couple of days ago, I heard my colleague John Robbie speaking to a psychologist, and they were talking about clutter and how some people's brains are attuned to clutter and they work better in that environment. So what is the science behind clutter? Help me, please.
Well, my teacher at school had a sign on his desk that said, an untidy desk is a sign of genius. I clearly subscribe to this same approach, as do you, Reedy.
Yes.
It's horses for courses. Some people find it being in a cluttered, messy environment extremely difficult to deal with, because they find that their attention is being drawn and distracted by lots of things all the time. In the same way, some people work very well with their music station on or with their headphones on, playing music while they're trying to work. Others, like me, find that tremendously distracting, because I tend to focus in enormous detail on what I'm trying to do, and any incursive noise, I find I try and attend to it and give it my full attention. So I'm not very good at screening out things going on around me. I tend to like to focus on things. Therefore, a bare, sterile, boring environment in which there's no distraction is good for me to work in. But at the same time, I do tend to make a mess, I must admit. So I like to have a part of the house I live in I make a mess in, and then a part of the house where I work where I keep it really tidy, because then I don't get distracted.
I so love hearing that. Thank you. And the thing is, when it's your clutter, you know where everything is. Well, at least I do.
I know where everything is.
I do too. I do too. So guys, leave me alone. Let's go to Daniela in Rosebank. Hi.
Hi. Thanks for taking my call. I have a hypothetical question. If you're traveling in an airplane at the speed of light, and you're sitting at the back of the plane, but you need to go to the loo in the front of the plane, could you ever get there? Would you be traveling faster than the speed of light, or what would happen?
Oh, hi, Daniel. This is all about relativity. And the point about relativity, and the reason it's called relativity, is that relative to you, light always travels at the speed of light. So, to an external observer watching you flying along in your aeroplane, they're going to see this aeroplane, or rather they're going to have a very unusual experience because the aeroplane is going at the speed of light, but they're going to measure something moving at the speed of light, and you're inside that object moving at the speed of light. But if you, sitting inside the aeroplane, make a measurement of the speed of light, although you're moving at the speed of light, and therefore, let's say you've got a torch in your hand and you turn it on, and it too is moving at the speed of light, the light beam that comes out of the front of the torch, as recorded by you or any of the other passengers inside the aeroplane in that frame of reference, is going to be light travelling at the speed of light. It won't be light travelling at the speed of light plus the speed of light. It doesn't work like that. And because light always travels at the speed of light, that's why time has to change to accommodate that fact, which is why you on your aeroplane flying along at the speed of light, for you time travel or time passes at, let's say, the normal time. But for somebody who's not on the aeroplane, it's going to go really, really fast. So when you come home, those people, after your flight, I mean, I've been on flights that seem to have lasted a lifetime. I'm sure that for those people on Earth, it really will have done, because they will have aged significantly faster than you have. And we know this is the case because people have done the experiment. You take a cesium clock, which is extremely high accuracy and very, very precise at keeping time. It's using oscillations of a cesium atom. You synchronize this clock, you have another identical clock which you put onto an aeroplane, and you fly the one on the aeroplane round the Earth, bring the two clocks back together. The one that stayed on the Earth and has therefore travelled more slowly has actually aged more than the one that's been on the aeroplane, travelling a little bit faster and therefore a bit closer to the speed of light, and therefore time has had to change to accommodate the fact that the speed of light cannot change, therefore time has to distort.
Thank you very much, Daniela, for a very brilliant question. Machaka in Doornfontein, hi.
Hi, Reddy. How are you?
Fine, welcome.
I'm good, man. I'd like just to ask Chris. After 10 seconds, already, I fart, and
You do what? You fight?
I fart.
Oh, that, yeah?
Yes, yeah. Every 10
you
seconds.
count like 1, 2, 3, 4. Every 10 seconds. Eh?
Even if I'm in a taxi, sometimes I become embarrassed. I say, but you know what? I know the taxis. Maybe the people don't think maybe there's some other smell coming somewhere. I just lose myself. I don't know what causes it.
So you want to know what causes severe? Do you call it severe or chronic? Chris, flatulence.
Flatulence.
Yeah. Every 10 seconds. Those were his numbers.
Okay. Well, the bottom line is, if you excuse that pun, Thomas is laughing now. The bottom line is that the gas inside you is the product of bacterial metabolism. You have in your guts literally 1 or 2 kilos of microbes, and they're hungry. And when you feed them with what you eat, yes, you absorb some of the nutrients, but there's lots of nutrients there that either you can't break down or you don't get the chance to break it down because the bugs get there first. And when the bugs break down some of these things, some of the products of their metabolism are gaseous. So you build up little pockets of gas in your intestine, and they slowly work their way through alongside what else is in there. And at various socially convenient or sometimes inconvenient moments, then there is an element of release. And hopefully it's a controlled release without the element of follow-through, which can be very embarrassing. And this can be known as a shart, which is a cross between something SH1T and a fart. But the bottom line is that about 1.5 litres of fart gas is passed from the average person every day. And so someone can try and say that they don't do this, but they absolutely do. Lots of people actually do it in their sleep as well, because everything relaxes when you go to sleep, including your anal sphincter. So you're more likely to chuff at night rather than during the day, or you're more likely to chuff loudly at night. And certain people have certain spectra or combinations of bugs in their guts that make them make more gas, and they also vary the composition of the gas they make. So everyone's farts are different and distinct.
So Machaka spoke to us about 2 minutes ago. How many times do you think he's farted since? Do the maths. I can't do it.
Well, 1.5 litres, 1,500 millilitres, and there's 24 hours in a day. So he's going to be doing this quite a few times an hour, isn't he? With a few mils.
And on that note, Chris, on that memorable note. You are so incorrigible. We'll chat to you next week.
See you soon. Bye-bye.
Bye-bye. We're going to make that available for you as a podcast. Thanks, Machaka, for the question.